Hi, this is CAT 2023 part 5 of the fifth part of the 5-part series for the slot 2 solutions. So here in this part, I'm basically taking a little tougher sums. I mean, what I would say would be definitely leave sums. I've taken 3 sums out here. That means the initial 19 were solvable. You could solve by different methods. Whatever clicks you could obviously solve. These 3 were on the slightly on the difficult side. It's possible that I may find it difficult because this involves a little bit more equations, and therefore I may find it difficult. It is solvable definitely, but difficult. Technically should be left. So let's look at how to solve. Now there are 2 approaches of solving this sum. So I'll look at both the approaches. Now first approach is trying to make this whole thing as a perfect square. So it's based on a property saying that x raised to m raised to n is equal to x raised to mn. Right? If I look at it out here, the first one I can write it as 2 raised to 2x square the whole square, making it a perfect square. I'm trying to make it as a square minus 2ab plus b square. That's what I'm trying to make. So the whole thing is, I can take 2 outside to make it 2 square. Same with the last term will be 2 raised to x plus 15 the whole square. 2 into 2, x plus 15 is 2x plus 13. Satisfies. So middle term will be 2ab, 2 into 2 raised to 1 into 2 raised to 2x square into 2 raised to x plus 15. If you look at addition of this, basically, I mean, if I write it, I'm rewriting this. This is nothing but 2 raised to 1 plus 2x square plus x plus 15, which is nothing but 2 raised to 2x square plus x plus 16, which is what the middle term is, satisfies. So that means if I rewrite this in terms of a minus b the whole square, it is a, right, minus b the whole square, okay, is equal to 0. Which means take a square root, a minus b is equal to 0, or a equal to b. Base is same, so power will be same. The 2x square will be equal to x plus 15, or 2x square minus x minus 15 equal to 0. We basically want sum of the terms. Remember, sum of a terms of quadratic equation of all the value of x is minus b upon a. In this case, b is 1, so minus of minus 1 upon a is 2, so you'll get half. Right? b out here is minus 1, a is 2. Substitute out here, you'll get the answer as half. Right? This is one approach of solving. Second approach, if I look at out here, you can try to take this on the other side. You get basically 2 raised to 4x square plus 2 raised to 2x plus 30 is equal to 2 raised to 2x square plus x plus 16. Now this whole thing is a power of 2. If you look at this, is a power of 2. Right? So that means all these terms are multiples. I mean, it's 2 into 2 into 2 into 2. So this also has power of 2. Which is only possible if these two are equal. If these two are different, I'm just giving an example. If these two are different, suppose I have 2 square and plus 2 cube. What will happen? You can take 2 square common, you will get 1 plus 2. You will get 2 square into 3, you will get. It will be 1 3 term will be. Right? So now, or if I take, let's say, 2 square plus 2 raised to 4. If I take 2 square common, we will get 1 plus 2 square, or 2 square into 5. But there is no 3 or 5 in the right side. It's all 2's. So to get all 2's, it's only possible if these two are equal. Which means 2 raised to 4x square has to be equal to 2 raised to 2x plus 30. Which means 4x square will be equal to 2x plus 30. Same way, 4x square minus 2x plus 30 equal to 0. Divide by 2. 2x square minus x plus 15 equal to 0. I mean, just check the plus minus as such. I mean, this is minus minus. So sum of all the terms, sum of roots will be minus b upon a, same as before. Minus of minus 1 upon 2, half. Technically, this step was not required. You could directly go from here. But anyway, the answer will be half, C option. Right? So I looked at 2 ways of approaching the sum. Both are difficult. It has to click in the sum. Or you need to practice similar sums so that you can get used to solving these type of sums. Okay, next. Again, 2 ways of solving this. One is, I would say, just substitute the values. I mean, for example, let's say y is, I'm just taking y is 11. Okay, y is more than 10, I'm taking y is 11. Minus x is more than y. Y is 11, minus x can be 12. So x could be minus 12. If I substitute out here, minus 12 upon 11 less than, if you look at x plus 3 will become minus 9. And y minus 3, 11 minus 3 will become 8. This doesn't satisfy actually. Actually, if you look at minus 12 upon 11 is more than minus 9 upon 8. It's a negative value, right? So here the 9 upon 8 is actually more than 12 upon 11. But because both are negative, minus 12 upon 11 becomes more than minus 9 upon 8. So it doesn't satisfy this condition. So A cannot be the answer. Let's take B. X is less than 0. I take minus 1. So I take x as minus 1. If I take x as minus 1, so minus x will become 1. Y is more than that, I take y as 2. Substitute. So we'll get minus 1 upon 2. X plus 3. Okay, so you have minus 1 plus 3, which is 2. Y minus 3, which is 2 minus 3 will be minus 1. Again, you will see that minus half will be more than minus 2. So this also doesn't satisfy. Right. Now we have third, y is less than 0 I'm taking. Y is less than 0, I taken y is minus 1. Yes, y is minus 1, x is less than y. So x I can take, minus x I can take as minus 2. So x will be 2. Minus 2 is less than minus 1. So x will be 2. Substitute out here. 2 upon minus 1. Right. X upon y is 2 upon minus 1. X plus 3 is 2 plus 3, which is 5. And y minus 3 is minus 1 minus 3, which is minus 4. You will realize minus 5 upon 4 is bigger than this. This satisfies. If you want, you can check with the last sum also. X upon y is less. If you look at, I have put the first minus half out here. Okay. X is minus 1 upon 2. Y is 2. Then y will be 2 upon minus 1. Right. Technically, if you look at, substitute some values and check out, you may feel clear it may not satisfy. Put values, go about it. But moment you get C, you can mark the answer as C. Or you can substitute values for a D option also and check out whether it satisfies or not. And then work on accordingly. Right. So x upon y is less than y upon x. Half will be less than 2 upon 1. And then you can try to figure it out. If I put x as half, okay, so x plus 3 will be 4, y minus 3 will be negative. So again, this will be more, doesn't satisfy. So automatically, only C option satisfies. Another way of going about is trying to remove the denominator. So let's take each case and solve. If I look at x upon y and x plus 3, y minus 3. Now if y is positive, y minus 3 is also positive. If I want to remove denominator, I can multiply by y into y minus 3 on both the sides. So into x upon y. I mean, using this because both are positive. So will be less than x plus 3 y minus 3 into y minus 3. Because y is more than 10, both y and y minus 3 will be positive. If you multiply by same positive value, both the side values does not change. So y gets cancelled, y minus 3 gets cancelled. You will basically get x y minus 3x is less than x y, okay, plus 3y. To solve it, x y gets cancelled, 3 will get cancelled, get minus x is less than y. A option doesn't satisfy. Same I take this one, y less than 0. If y is less than 0, y minus 3 will also be less than 0. Because y is negative, y minus 3 will also negative. So y into y minus 3 will be then positive. Okay, if y is less than 0, y minus 3 will also be less than 0, which case y into y minus 3 is positive. So similarly, same thing I can multiply. Multiplying by y into y minus 3 for x upon y. Right, x plus 3 upon y minus 3 into y into y minus 3. You get the same thing. Let minus 3x is less than 3y, or you will get minus x is less than y. Here it satisfies. So C is the answer. You can directly mark the C. Because you got it by calculation that minus x is less than y, you can mark the answer as C option. So either way, I normally prefer substitution, substituting simple values and getting it. But for that, you need to be really good at calculating fast to eliminate options. Else, you can obviously solve by equation and get the answer. Here, this is based on the no real roots, quadratic equation. So when you have quadratic equation, no real roots, the first thing that should click is b square minus 4ac is less than 0. That's the first thing should click. Which means you need to convert this into quadratic equation. Expand it. X square minus 2x plus 1, right? Plus 2kx plus 11 equal to 0. So x square together plus you can add 2k minus 1x. I'm combining these two, right? Plus 12 equal to 0. If you do b square minus 4ac, b is 2, k minus 1 is b, square minus 4 into a is 1, c is 12 is less than 0. 4 into k minus 1 the whole square, okay, is less than 48. 48 can go outside. Of k minus 1 the whole square is less than 12. Remove square root. K minus 1 is either less than root 2, root 12 or more than negative. Whatever. So root 12, if you get it, I mean, if I just take root 12, will be something around 3 point something. So k will be less than 4 point something. So largest value of k will be 4. Okay, largest value of k, which is what we want, the largest integer of k will be 4. By solving this, you get k is less than 4 point something. Root 12 is 3 point something. Remember, root 9 is 3, root 16 is 4, root 12 is 3 point something, plus 1 goes that side, it becomes less than 4 point something, 4. Substitute here. So you get 4 upon 4y plus 9y. You want the least possible value. This is nothing but 1 upon y plus 9y. Since you want to take the least possible value, you can take the property saying AM is more than equal to GM. The property which is the AM, arithmetic mean of two numbers, is more than equal to geometric mean. So 1 upon y plus 9y upon 2, arithmetic mean, is more than equal to geometric mean, which is root of 1 upon y into 9y. Y gets cancelled, root 9 is 3. Okay, and this is 1 upon y plus 9y upon 2. So 1 upon y plus 9y will become more than equal to 6, 3 to the 6. That's what we want. K is 4, remember. So we want, 1 upon 4y, it is 4 gets cancelled actually. So k upon 4y, that means k is 4. 4 upon 4y plus 9y is what we want, which is 1 upon y plus 9y is what we want, is more than equal to 6. Right? That means y the real positive value, then the least possible value of this. So least possible value will be 6. More than equal to 6, so least possible value will be 6. You get the answer. So these three sums in the CAT were a little calculated. The rest were sums were fine, you could do it fast, quickly. These three sums were a little time consuming and it should click that this is the way to click. This is fine. Again, I feel that moment you see no real roots, you should make out b square minus 4ac 0. Even previous sum, you could substitute the value and get the answer. I thought the first sum in this series was the little on a difficult side. Right. I hope this is clear. Go through all the 5 solutions, see which methods you're comfortable with and see if you can apply those methods. The moment you apply more those methods, you will be comfortable with solving. Thank you.